projects. In this video, we are going to explain about a project titled Heart Failure Prediction using Machine Learning. Heart failure is a critical medical condition that affects the millions of people worldwide. Early detection and the intervention are crucial to improving the patient outcome and enhancing the healthcare efficiency. Leveraging the power of advanced machine learning algorithms such as logistic regression, SVM, KNN, Naive and random forest classifier, our project aimed to develop an accurate and efficient system for predicting the likelihood of heart failure in the individuals. By analyzing a diverse set of patient data, medical history, and the relevant features, our goal is to empower the healthcare professionals with valuable tools for the early diagnosis, personalized treatment, and the improved heart health management. And the objective of our project is to develop a comprehensive and accurate system for the early detection of heart failure in the individuals. Leveraging a diverse set of machine learning algorithms, including logistic regression, SVM, KNN, Naive and random forest, our goal is to build the robust model that can effectively predict the likelihood of heart failure presence based on the patient data and the medical features. Through the extensive data analysis and the model training, our project aims to empower the healthcare professional with the valuable tool for timely intervention and the personalized care, leading to the improved patient outcome and the promoting cardiovascular health. Ultimately, we aim to contribute to the enhancement of the heart failure management, reducing the healthcare burden and improving the overall patient well-being. And these are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7, Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the library. The project begins by importing the essential Python libraries such as NumPy, Pandas, Matplotlib, sklearn, Flask, etc. These libraries provide the necessary tools and functions for the data manipulation, visualization, machine learning model building, and the web development. The second one is importing the dataset. The heart failure dataset containing of patient data, medical history, and the relevant features is imported. This dataset serves as the foundation for training and evaluating the machine learning model for the heart failure prediction. And the third one is data pre-processing. Data pre-processing techniques are applied to clean and transform the dataset, this including the handling the missing value, encoding the categorical variables, scaling the numerical features, and removing the irrelevant or redundant data to prepare it for model training. And the fourth one is dataset splitting. The pre-processed dataset is divided into the training and the testing set. The training set is used to train the machine learning model, while the testing set is used to evaluate the performance on the unseen data. And the fifth step is model building. Multiple machine learning algorithms are built. The first one is logistic regression. It is a linear classification algorithm used for binary and the multi-classification tasks. In the project, logistic regression is applied to predict the likelihood of the heart failure occurrence based on the patient data and the medical feature. It models the relationship between the feature and the class probability, making it interpretable and suitable for understanding the impact of individual features on the heart failure prediction. And the second one is SVM. It stands for Support Vector Mission. Is a powerful supervised learning algorithm used for binary and the multi-classification tasks. In the project, SVM is utilized to classify the patient into the two classes, those with the heart failure and those without. SVM seeks to find an optimal hyperplane that best separates the two classes, maximizing the margin between them. SVM can handle the high-dimensional data and the non-linear decision boundary, effectively making it suitable for the complex classification problem like heart failure prediction. And the third one is K-nearest neighbor classifier. It is a lazy learning algorithm that classifies the new data point based on the majority class of the K-nearest neighbor in the feature space. In this project, the K-neighbors classifier is used to predict the heart failure occurrence based on the similarity to the other patients in the dataset. K-neighbors classifier is simple, easy to implement and can perform well with the appropriate choice of K and the distance metric. And the fourth one is naive Bayes. Naive Bayes is a probabilistic algorithm based on the Bayes theorem. In the project, naive Bayes is used for the heart failure classification when features are assumed to follow the certain distribution despite its naive assumption of feature independence. Naive Bayes often perform well in various classification tasks, especially with the continuous features. And the next one is random forest classifier. It is an ensemble learning method that combines the multiple decision tree to improve the classification accuracy and reduce the overfitting. In this project, the random forest classifier is used to build a robust model for the heart failure prediction. Each tree in the forest is trained on the random subset of the features and training samples, and the final prediction is obtained by aggregating the prediction of the individual trees through OT. And the next one is accuracy comparison graph. After training and evaluating each model, the performance metrics such as accuracy are computed and compared to identify the most suitable model for the heart failure prediction. And the next step is training the model. Each algorithm is trained on the pre-processed heart failure dataset to learn the pattern and the relationship between the features and the heart failure occurrence. And the next step is user gives the input. The Flask web application is created to allow the user to input the relevant information for predicting the heart failure. The given input is pre-processed per prediction. The user provided input is pre-processed similarly to the training data, ensuring it is in the right format and condition for the model to process. And the next step is trained model is used for the prediction. Each trained machine learning model including logistic regression, SVM, K-nearest neighbor, naive Bayes and the random forest classifier is used to predict the likelihood of the heart failure occurrence for the given patient. And the next step is final outcome is displayed. The prediction from all the models are collected and the final outcome is displayed on the Flask web application. The user is informed about the predicted heart failure occurrence and the relevant performance metric, providing the valuable insight for the early detection and personalized medical attention. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it, the static folder containing of the style sheet within it, and the template folder containing of the index file in the form of HTML document within it, and the app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handle the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the heart failure prediction is an IPYNB file which contains a combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the model is an pickle file which contains the algorithm information and can be loaded into the project code during the runtime to utilize the trained model for the various tasks, such as making the prediction on the new data, performing the specific operation. And for the execution of the project, first we need to copy this code folder and then open the Anaconda prompt. Here we need to change the location of the disk of F because our code folder is present in fdisk. Then write the command cd space and paste this code folder path. By this it will change the current directory to the code folder's path. And then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script to check whether having the runtime errors or the logical issues within it, and then click on the enter button. After running the app.py file, the Flask framework will host the application locally at the default address like this. We need to copy this code folder address and then open any of the browser. I prefer to use the Google Chrome, and paste this link and then click on the enter button. Here it will predict it to this page containing of the title of the project and some input details that are need to be filled, and the age of this person of I'm giving as 50, and the ejection fraction I'm giving as of 30, and the serum sodium is of 138, and the serum creatinine is of 1. And then click on the predict button. Here the patient is not likely to have an heart failure. In this way we can predict the heart failure by using this input. And here I'm entering the other detail of age 75, and the ejection fraction is of 20, and the serum sodium is of 130, and the serum creatinine is of 1.9. And then click on the predict button. Here the patient is likely to have heart failure. In this way we can predict the heart failure by using the various machine learning algorithms. And this is the comparison graph of accuracy, where x-axis represents the score and the y-axis represents the algorithms we used in this project. And in conclusion, our project on heart failure prediction using the machine learning has successfully achieved its objective by leveraging the machine learning algorithms such as logistic regression, SPM, KNN, Neobayes, and random forest. We have developed a comprehensive and accurate system for predicting the likelihood of heart failure in the individuals. The project success holds the potential to empower the healthcare professional with the valuable predictive tool, enabling the early detection and the personalized medical attention for the patients at risk of heart failure. Ultimately, this transformative project contributes to improving cardiovascular health outcomes and promoting a healthier society with enhanced heart disease management and the patient care.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.